Hello, everyone. How are you all? Can you hear me? If you guys can hear me, just type message into the message box. Yes, cool. So everyone can hear me. That's great. So आज का सेशन स्टार्ट करने से पहले आई वुड लाइक टू आस्क किस किसने पहली बार ज्वाइन किया है यहाँ. जस्ट ड्रॉप द मैसेज इन द मैसेज बॉक्स. सो आई एज्यूम कि इस बाकी सब ने पहले भी ज्वाइन किया है, नॉट लखनऊ ये सेशन. तो दिस सेशन इज अबाउट पेपर रीडिंग सेशन. यहाँ पर हम एआई से रिलेटेड ब्रेक थ्रू पेपर्स को रीड करेंगे और उनको बहुत सिंपल कॉन्सेप्ट में समझने की कोशिश करेंगे. तो आई थिंक लखनऊ एआई लैब्स ने पिछले साल ऑलमोस्ट 5 to 6 पेपर्स रीड किए थे. This time we will go with a new energy, new zeal to read some good papers. So you all are welcome here. बहुत बहुत स्वागत है आप सभी का. वेलकम टू लखनऊ लैब्स की इस साल की पहली एमएल पेपर रीडिंग सेशन को ज्वाइन करने के लिए. मैं हूं प्रशांत कुमार शुक्ला, आज आपका होस्ट. एंड आज हम बहुत सारे इंटरेस्टिंग टॉपिक्स से होकर गुजरेंगे. और आज का रिसर्च पेपर है अ सर्वे ऑन agentic protocols. So first of all, I would like to thank you all of you कि आप सबने आज अपना संडे इवनिंग का टाइम दिया और इस सेशन को ज्वाइन किया. So I would like to ask anybody know about agents already. If you know already about the agents, please kind of show or raise your hand. I'm waiting for your answer. So I think काफी लोगों ने पहले से सुन रखा है. So आपकी स्क्रीन पर एक पॉपअप आया होगा, जल्दी जल्दी से वहां पर अपने आंसर को रजिस्टर कर दीजिए. आई वुड लाइक टू सी कि कितने लोगों ने पहले से देखा हुआ है या जाना हुआ है एजेंट को. ओके, गुड, दैट्स कूल. सो एक्चुअली देखिए, आज की दुनिया में सबसे ज़्यादा बज़ है एआई एजेंट्स. हर जगह सुन रहे हैं कि ऑटोनोमस एजेंट, मल्टी एजेंट सिस्टम, एजेंटिक एआई. बट लास्ट हमने स्टडी जैम के सेशन में जहाँ एआई कम्युनिटी के थ्रू ऑर्गेनाइजेशंस में पार्टिसिपेट किया था, वहाँ पर कई सारे इवेंट स्टडीज एआई एजेंट्स के बारे में जाना कि उनको कैसे बिल्ड करते हैं. अगर आप में से किसी ने नहीं उन सेशंस को ज्वाइन किया है, दे कैन डेफिनेटली ज्वाइन अपकमिंग सेशंस एंड प्रीवियस सेशंस आर already available on YouTube channel, so they can also visit there. आज का पेपर एग्जैक्टली हम उन एजेंट्स के बारे में बात करेंगे जो एजेंट्स आपस में कैसे कम्युनिकेट करते हैं. लाइक हमें पता है कि वेबसाइट्स से कम्युनिकेट करने के लिए हमें सम काइंड ऑफ एपीआईज चाहिए होती, बट हाउ द एजेंट्स विल कम्युनिकेट. सो वी विल डिस्कस अबाउट एआई एजेंट प्रोटोकॉल्स. एक दूसरे से एजेंट्स कैसे बात करते हैं. और आज के सेशन को कंडक्ट करने के लिए हमारे साथ हैं ज्योति में. So, Jyoti, welcome to Jyoti to our session. She will conduct today's session and she will read and go through with this whole paper. So I hope you all are quite ready for that. And let's welcome Jyoti ji. Jyoti ji, can you hear me? Okay. So let her rejoin. Until then, we have other things to discuss. अ, देखो, ये लखनऊ एआई का इनिशिएटिव है, ये पेपर्स को रीड करने का, ब्रेक ब्रेक थ्रू पेपर्स को यहाँ पर लाकर डिस्कस करने का, ताकि हम अपने लखनऊ में एक ऐसा इकोसिस्टम बिल्ड कर पाएँ जहाँ पर अ, हम एक कॉम्प्लेक्स टॉपिक को आसानी से समझ सकें और उन्हें बिल्ड कर सकें। ठीक है, हमारा गोल सिंपल है, लखनऊ में एक रिसर्च कल्चर बिल्ड करना। टियर 1 सिटीज़ में लोग रेगुलरली पेपर्स पढ़ते हैं, डिस्कस अबाउट इट एंड दे आल्सो डू डेवलप। बट लखनऊ एक पोटेंशियल सिटी है जहाँ पर हम ये सारी चीज़ें कर सकते हैं, और आई बिलीव इन ऑल ऑफ यू गाइज हु हैव जॉइन्ड टुडे बिकॉज यू ऑल हैव इंटरेस्ट. Today we will discuss very deeply. Okay. Jyoti ji, can you hear me? कितने लोगों ने ये पेपर पहले से देख रखा है या पढ़ा हुआ है? You can't hear me? Anybody else? मेरी आवाज बाकी सब लोगों को आ रही है? That's great. So, Jyoti ji, आप can you unmute yourself? So,
No, am I
hi.
audible?
Yes, you are audible.
But I can't hear you, Prashant, at all. Uh, just noticed your lip sync. I can't hear you. I don't. There's some problem with the stream. It shows stream is not live yet sometimes.
Yeah, okay. So, it's live now. It's working. Everyone else, like Jyoti ji, you are audible.
Okay, sure. Then I'll take over. So, a very good evening to everyone present here, and thank you for joining on Sunday for a research paper reading session. So, my name is Jyoti Nigam, and I'm currently working as a data scientist at Grad School of Technology. Apart from that, I am also co-founder of a community called as C2AI, which is basically a community for cybersecurity and artificial intelligence research. I have about 3 years of work experience in the industry as a data scientist. And I also love writing technical blogs, and I'm also a member of Google AI developers community. So the today's session is about research paper reading, and it's actually a survey paper, not even a research paper. And I do have this paper with me present here, and it's a 30-page paper. So, first of all, it's not possible for me to cover a 30 pages of paper in 1 hour 15 minutes of a session. So, what I've basically done is I've uh, created an entire breakdown of this session in this Miro board. I hope so. My screen is visible as well for everyone. Can I just get a confirmation if my screen is visible? Um, okay, let me try sharing it again. Is my screen visible now? I mean, I see few writing yes and few writing no, which is quite strange. Um, okay, the half of the audience can see my screen. Half cannot. Maybe you can try refreshing the stream. Prashant, can you please confirm if my screen is visible once over chat? Okay, can you see my screen now? I think there's some problem with the platform, which is fine. But uh, those who are on Communal, if any of you can confirm. Okay, fine. So I think some of you can see my screen. Those who cannot, please try joining the YouTube link. Uh, you'll be able to see it there. So I was telling that this research paper is basically a 30 pages survey paper about AI agent protocols. And it is practically not possible to cover such an extensive paper in 1 hour 15 minutes of session. So what I've done is I've divided this entire paper into multiple chunks, and we'll be going through each of them. So I'll give the detailed overview of what this paper contains, and after this session, I'll make sure that you all can read this paper very easily. And I would still advise you not to read this entire paper in a go. Whenever you are going forward to read any research or any survey paper, it is a very exhausting process, to be honest, and it should be done in parts. So after this session, I'll ensure, like, it guarantee like 100% that you'll understand each and everything what this paper contains, and you'll be able to follow this paper through this board. I'll share the link of the board as well. So this paper is a very important paper. It is a very recent paper, which is about survey of AI agent protocols. Now there are two important words, which one of which is an AI agent, and second is protocol. Can we run a poll? And I want to ask how many of you know the term protocol? And if anybody wants to answer, would probably be more better. Meanwhile, this research paper is written by Yang Sean Yang. I don't know if I'm pronouncing him right, along with his fellow mates of Shanghai Jiaotong University. And it has a GitHub link as well, which is actively maintained. So this GitHub repository was updated last in April 2025. Um, so this basically introduces you to all the existing protocols in the AI agent domain. So there are two important terms, as I said, one of which is agent and second is protocol. Can we run a quick poll? Would someone want to answer what do you mean by the term agent and the term protocol? I'm looking forward for the answers. Protocols are like rules which make AI agents work together. Okay, partially correct. So all of you would have heard of the term HTTP, if I'm not wrong, right? Or let us talk about us. So, for example, today's session, let's say if there are two friends talking to each other, or let's say if I'm talking or interacting with you, probably it is done through some medium, and that medium is a language, right? And that language is English. Now, whenever we are speaking any language, there are some sort of rules that we follow, and that forms the grammar of that particular language. So protocols are basically the rules that allow us to have an interaction. So I see a lot of responses in chats and all of them are correct. So thank you so much for responding. So basically, there are a lot of protocols which you might have studied. For example, HTTP is a protocol that defines how the data transfers over web. Then there is HTTPS. Then there is TCP protocol, which is about data transmission. Then for file transfer, there is FTP protocol. So now in this paper, we are talking about protocols for AI agents. Now, the second important term, that is AI agents. So what do we mean by the term AI agent? Would anybody like to define it? I have a nice picture here to demonstrate. I mean, all of you would have heard of this term, and probably this decade has been called as the decade of agents, and there is a lot of talk around the term agents, AI agents, of course. Does tasks automatically? Okay. I'm looking forward for more responses. Software program that operates on AI. Okay. So see, we all have been using LLMs extensively. So we all prompt or we all talk with LLM by writing our questions and then we get answers to it. Now, one problem that arose was that these LLMs sometimes start making fake information. So let's say that you are asking um, about let's say you're feeling hungry and you want to order food, and then you probably prompt LLM that what food items can I have in my city. So what will happen basically is that it will give you very generic answer. Probably it doesn't knows what are your food choices. It doesn't knows what food options are available within your city, and it just gives you generic answers like maybe you can maybe some vegetarian options, some non-vegetarian options. Then second advancement that was done was called as RAG. RAG stands for Retrieval Augmented Generation. Now, let's say that somehow your LLM has access to all your previous orders that you probably would have made on Swiggy and Zomato. Now, what it will do is next time when you ask it for any food suggestion, it will probably go to that data. It will query that data where maybe that data is stored in a database, and it queries that data and it gets your food preferences, and then it gives you an option of what all food items can you probably order if you're feeling hungry. And the more advanced option is that there is an agent and you just say that you feel hungry and you want something to arrive to your home within 30 minutes. What an agent will do is basically it has access to your data. It can connect with the apps like Swiggy and Zomato. It can navigate through those apps. It knows your food preferences as well. And based upon that, it finds what is the uh, most recent or orders placed by you, and then which option is available, which food item can be delivered to you within 30 minutes, and it will place an order for you. And then you all you need to do is just probably open the door when the parcel arrives and then have your food and enjoy. So this is a very basic difference between LLM, RAG, and agents. So agents are LLMs with hands and legs, or basically LLMs are brain. And then if you have given them hands to take actions, that is what constitute an agent. Now, this is a diagram of an AI agent. So AI agent has several components. For example, it has memory. in which it can store information. It has got tools. Tools can be anything. Like I told you, it has access to your application. So it might be accessing your Swiggy or Zomato application through an API. It can perform tasks. So it performed multiple tasks. First of all, it checked what all orders had you made in the history, and then it found out what is the option that is available that delivers you the most uh, quickly. And then it decided to place an order for you on your behalf and did the payment. And then these were like multiple tasks. And it was able to interact with the environment. So this is the definition of an agent. This is a more architecture diagram, a formal diagram of an AI agent. Now, this paper that we are talking about, which is about survey of AI agent protocols, is basically defining how these agents should be interacting or communicating with each other. Now, we talk about multi-agent systems wherein we can have multiple agents. Let's say that you are working on making a product. Now you can be someone who is working alone on that particular project or a product, or let's say you decide to write a research paper, so maybe you are working on that, writing on that research paper alone. So you can be the one who is doing the entire planning stuff, you can be the one who is doing the writing stuff as well, and you can be the one who is doing who's handling the publishing part as well. And maybe if you're working on a project, it can be just you working on the planning part and then writing the code for both front end and back end, and then maybe deploying that project as well. Now, instead of that, if you work in teams, if you have 4 or 5 of your friends working along with you, so each friend can take on one responsibility. Let's say somebody is responsible for the ideation part. One of your friend is responsible for building the front end. One of your friend is responsible for building the back end, and you have multiple people working all together. So that is a multi-agent system. Now, this sounds easy, and it may look that okay, if we are able to build such a system, we would achieve, we will be able to actually do a lot of things, and we are able to do a lot of things. So companies like Microsoft, companies like IBM, they're already having agents operating at an enterprise level who are who are actually handling a lot of tasks, such as the customer support agents are there, agents for data analysis are existing. But then we need a standard way. We need to define a standard way on how these agents should be talking to each other. For example, if you're interacting with the friends in your team, probably you will do it in the language Hindi. And then you might have a very cordial relationship with everyone, and then you're very friendly with everyone. Compared to when you're working in a team with unknown people, where you don't know them already, so then it might be a very formal kind of an arrangement. So we needed protocols for agents to communicate with the outer tools. Tools can be anything, it can be an API, it can be coding software, anything. And then we also needed protocols that defines how agents should be talking with each other. And there are several protocols that are existing. So there is an image, this image probably, which defines that there are a lot of aging protocols that are actually existing in the market. And this paper covers, it offers a very detailed survey on this aging protocols. So how this paper is organized is that the people, the researchers have divided the protocols into two categories. One is context oriented protocol, and the second is inter-agent protocol. Within context oriented protocol, also there are two categories. One is general purpose agent protocols, and the second is domain specific agent protocols. So you can see that there are a lot of protocols that are defined here, like there's MCP. I'm sure many of you would have heard of MCP. There is agents.json. There are protocols like ANP, A2A, AITP, ACOMP, and then again, interagent, there are so many protocols. Now, of course, these are so many protocols, but then within this paper itself, they've given a table which tells us that which protocol is at which development stage. So for us right now, the most important protocol is the MCP protocol, which is currently the industry standard. It is the de facto standard and it is being implemented widely. All these other protocols, they have told us whether they are in the drafting stage means it is just a written idea, and maybe there is some early code implementation of that protocol, but it doesn't exist, it is not fully launched or tested properly. There are some protocols in the landing stage, which is that this protocol is launched publicly, but then there is no official support for these protocols as of now. And then there are some protocols that are marked as concept level. So these concept level protocols are just in the research phase. So our focus would obviously be on some of the important protocols like MCP, A2, ANP, and Agora protocol is one protocol. I just want to know how many of you have heard about MCP, and if there is any understanding you have of the MCP protocol. What does it stands for actually? Can we run a quick poll where everyone can answer whether they have heard about MCP? It's a model context protocol. Okay, I got the full form. Anybody who knows about this protocol? Okay, I'll be using a lot of images. I have marked all the important points in this research paper. There are a lot of post-its present here, which you can read, that covers everything in easy analogies with some examples. But of course, I'll be covering this entire session through pictures. This can help you later when you're reading the research paper. Okay, so system that helps AI agents. Okay, so MCP or Model Context Protocol, as I said, it is the de facto standard. It was introduced by the company Anthropic. You would have heard of the model cloud. And it is one of the most widely used protocol right now. Now, how this protocol is organized is this is the architecture diagram of this protocol. So this protocol has four main parts. One is the host. Now, host can be anything. Host is basically your LLM. It can be your LLM within the VS Code. It can be your cursor. It can be your desktop. And then there is something called as MCP client. Now, what is an MCP client? It is basically a bridge between the host and the server. And the client implements this MCP protocol to connect with the server. This server, all these servers that you see, they are all connected with all the external tools and resources. So, for example, let's say that you have implemented a system that is you're working on a project, and that project is present on GitHub. Now you implemented MCP protocol, MCP architecture, and now you have used GitHub tool, integrated the tool, and you have the code present in your system in VS Code. What this tool does is that it can read all the code within your system. It can pull in the GitHub request, and then it can actually prompt the agent or the LLM to actually address the pull request or the feature request, whatever they are in that are present. It can do changes in your code, and then it is able to push that code on that repository. So this is one such system. Another system that you can build would be, let's say, your computer has all the access to your Slack channels. Like you have implemented a Slack MCP server, you have implemented a calendar, and what it does is it basically finds out what all meetings are scheduled. You have an agent that is attending your meetings, and it is able to navigate through all the Slack messages in the team which you are working in. And it is able to actually summarize all the data within these Slack channels and whatever discussions happened over the meeting in a document format, and it uploads the document into your drive. So this is how this entire architecture works together. Now, why is MCP so famous, or why do we hear about it a lot? Because it makes it very easy for us to interact with any sort of agent and any sort of tools. So we can have agents that can it can be, let's say, OpenAI. We are using OpenAI LLM, or we are using Google Gemini LLM, or we are using Cloudy. Anything we are using, maybe some Anthropic model, any model that we are using. And then there can be multiple tools as well. Now, every LLM has their own declaration, has their own documentation on what all uh, facilities or methods do they provide, and then these tools have their own definitions or their own documentations. Now integrating these LLMs with these tools, external tools, was a very tedious task when MCP was not there. What MCP did is, let's say if you wanted to connect to Slack, you had to do through some different the entire code that was to be written was a different piece of code. If you had to connect Google Calendar with your LLM, it was a very different piece of code that needs to be written. Now, MCP is like the USB dock that you connect your laptop with. Now, you have this one single port. Imagine your laptop to be a client. You have this one single port and you connect this dock to this port, and now you can plug in any number of tools here. You can connect, there are server, and each server has access to some tools. Now you can plug in any tools similar to how you plug in USB cables to the dock, and then it becomes very easy for the host to just interact with the client and then send request to the server through this MCP protocol. So this is the reason why it gained so much attention. And again, this is another such diagram of MCP architecture, which explains you how this entire thing is organized. Now you can, there are a lot of pointers mentioned. What were the advantages of MCP? Like it addressed this fragmentation issues, as I told you, that LLMs interacting with external tools. Now it also enhances privacy and security. You can go through the actual website, the documentation of MCP, and you will find a lot of implementations there. So MCP is a context oriented protocol. Basically, it defines how your agents should connect with the external tools to get the context. Now, this completes the first part, which is it is a general purpose context oriented protocol. Now, then there comes another topic, which is like domain specific protocol, context oriented protocol. Now, when I'm talking about context oriented protocol, what I mean is I am trying to define protocols that defines how agents interact with the tools of the external world. This is what is defined by the context oriented protocol. But then there is another category, which is inter-agent protocols. When I'm talking about inter-agent protocols, I am basically defining protocols that define how an agent should be interacting with the another agent. Now there is within the context-oriented protocol, we talked about MCP. Now the second domain-specific protocol is agents.json protocol, and it is very similar to robots.txt file. So have you heard about robots.txt file? Is anyone aware who works on the web development or is aware of this field? So can anyone answer what is robots.txt file? What does it do? I'm sure you would have heard of this term. I mean, it will be very easy for you to understand agents.json if you know that already. Um, Correct. So it tells what pages Google can index. Basically, these are crawlers that can crawl through the web pages, and they define how what pages Google can index. Similarly, how these robots.txt file exist in the web, we can have agents.json file. Now, these agents.json file can be defined by the website. Now, this website, whatever website we are trying to query, let's say if it contains the agents.json, it basically tells your agent, there is an agent who is trying to get some information from this particular website. It will tell this agent, how is this entire website organized? And agent has all the instructions present in this JSON file. It reads through this file. It actually plans on what actions to take based upon this file, and then it is able to work on a particular tasks. So this is what an agents.json protocol is about. It is an open source protocol, and this is how it is organized and can be compared with robots.txt file. This completes the context oriented protocol section. I'll take the questions in the end because, as I told, this is a very comprehensive survey paper and there are a lot of topics that I need to cover. So maybe you can write down your questions in chat if you've got any right now, and I'll take all of them at the end. I'll move to the inter-agent protocols. Now, inter-agent protocols, as I said, they define how an agent is going to interact with another agent. And then there are a lot of protocols that exist within this category. Few of them that we should be knowing is ANP protocol, which is Agent Network Protocol, which is an again open source protocol, and this is the architecture diagram of the protocol. So this entire protocol has three layers. The first layer is the identity layer, which is basically where we validate the agent identity, and it is end to end encrypted. It assigns some ID to the agent so that we are sure that this agent is authorized to access some of the data. Then there is meta protocol layer, which is basically it tells the data about the protocol, like what all protocols are being defined, how do we need to debug, how do we need to test. And then the main part is this layer protocol. So application layer protocol is where we have what tasks can agent perform, and which agent can interact with another agent, and how these agents basically one manager is there that is existing there to manage all the interactions that is happening between all the agents. So why this ANP architecture we have discussed is because again it is an open source protocol. You can imagine ANP architecture to be something like the HTTP protocol for the web. So, in a way, how HTTP protocol is important for the web, it is an again open source protocol for the web to have an interaction. Same as the NP protocol. The next important protocol that we have is A2A protocol, and I'm sure you would have heard of it, which is agent to agent protocol by Google. It was released in 2025, and it is an enterprise level protocol. This is the diagram of A2A protocol. As I said, that inter-agent protocol are basically protocols that define rules on how agents should be communicating with each other. So if you notice, A2A protocol, what it does is it defines certain rules on how agent 1 can interact with agent 2. And then we have MCP protocol here, which defines how this agent can actually interact with the outside tools. What rules should it follow, or how should we be defining how agents are talking to the outside tools? And these tools can be anything, maybe interacting with a database, maybe interacting with an API, maybe interacting with a file system, or a GitHub repository, or a Slack channel, anything. So using A2A protocol, we can build multi-agent system, and this protocol is more used at an enterprise level right now. And again, you can find out the documentation of this protocol, wherein you can navigate through the code implementation of it. Apart from this, there are a lot of protocols that are defined. So I'll cover them briefly because, as I said, these protocols that you see here that are defined in this research paper are basically either in landing stage or drafting stage. So they do not exist in terms of implementation. So the most important protocol that we should be knowing is this ANP, A2A, and MCP, and then there's one more Agora protocol that I'll be talking about. Now there is this protocol called as AITP, which stands for Agent Interaction and Transaction Protocol, which basically tells, let's say if there are if you have ever done an online banking transaction, so if you want to transfer money from one bank account to another bank account, you would probably do through a net banking app. So what that application does, or how that process of transferring money happens, is it is similar to how this agent interaction and transaction protocol works. So it basically defines rules that allows agents to communicate securely across some boundaries. Then we have Agent Connect protocol that was introduced by Cisco in 2025. And again, it is like, let's say that you have a USB cable, and that USB cable can be used to charge your phone, as well as it can also be used to connect to your laptop. So Agent Connect protocol is basically a plug-in play protocol, which defines rules that can allow us to start the conversations, pause, resume, and manage. Then we have Agent Communication Protocol, which was again released in 2025, which is about how do, let's say, there we are using Zoom for meeting, or let's say we are using Communal right now for interaction, and then I'm also using English as a language, as a medium to talk to you. Similarly, Agent Communication Protocol basically defines rules that allow agents to communicate across different teams or across different frameworks within the organization. Then we have Coral Protocol as well. It is a decentralized protocol and it is again an open source protocol. So you can read about it again in detail. I'll move to Agora protocol, which actually is a very important and interesting protocol for you to know. So agents face a trilemma, a communication trilemma, which is defined in this image. So basically, if an agent is at work, it should be doing three things. It should be able to handle different types of tasks and different message requests that is coming from user. It should also be efficient, like it should not make too many requests. It should be cost effective, and it should be easy for us to use or deploy in a production level system. So to address all these things at once, Agora protocol was introduced. And how it works is, it is a very interesting protocol. So let's say that you decide to order a food from a restaurant. Now it assigns something called as protocol description, PD. Um, you can compare it with a hash number. So you decide to place an order. That app which receives the order request will check, are there any delivery agents, service agents available? If yes, then it will probably share a number, a code, or you can call it as a PD to check whether there are some uh, agents who can take the order and can deliver the order. Once it has checked this, it will first check how is the traffic situation in the city. So it can tell you how much time will it take for us to deliver the order to you. So this is the second check it makes, and then again it shares some hash code. Once it has done, check the traffic condition, and let's say it is going to take 1 hour for us to deliver food at your home, then it will first check, out of all the available delivery agents, to whom can I assign this request. Once it assigns this request and we have a rider present, that rider will go to the restaurant while the order is prepared. It will reach the restaurant, will pick up the order, and then the food will be delivered to you. And in each and every step that is taking place here, there is this PD or hash number that is generated, which ensures that the entire communication or the process that is happening is all safe. The privacy is maintained and is secure, and it all happens step by step. So this is how Agora works. Um, Next, there are some domain specific protocols within the inter-agent system. So the entire, I'll come to this diagram to explain you in brief. this diagram. So we talked about general specific protocol, which is A and B, ACOM, P, Agora, and everything. Now, within the indoor agent system, uh, there is a domain specific protocol section, and within this, there are three categories: human computer, robot agent, and system agent. Now, what is human computer is basically the protocols that define how humans are going to interact with the computer. So, the interaction that happens between a human and an agent is defined by these protocols, and there are there is this LOCA, PXP, and WAP protocol that exist. Then there are protocols that are for robot agent communication. If I talk about this, if you've been to airports, you see that there is whenever there is a luggage, that luggage is put on some conveyor belt, and through that conveyor belt it reaches to the airplane. Similarly, let's say that there is this company Amazon, and there is a warehouse. Now, within that warehouse, there can be robots that are actually picking up the boxes and then putting it at the right places. So, the protocols that define how agents interact with the physical robots are defined under these categories: robot agent protocols. And then there can be protocols that define how agents are interacting with systems. Now, when I'm talking about systems, it uh, basically I mean is it can be anything as a software service. So let's say how an agent is interacting with your DevOps environment setup, how an agent is interacting with, let's say, Docker or Kubernetes setup within your organization, and then probably that agent is creating the containers, it is monitoring the logs of the containers, or let's say it is probably shutting down the containers. So there are some protocols that are defined there, which is like agent protocol and then LMOS protocol. So I'll cover them quickly in a brief manner, because again, like these are a lot of protocols, and then these are in mostly in the drafting stage, or some of them are in the research stage. So you can of course read about them if anything interests you more, and but we'll cover it in a way that we have some idea about what each protocol is. So for example, PXP protocol, it stands for predict and explain protocol. It is a protocol that lies in the human agent interaction category. So what it does is, let's say that you wrote a request to an agent. Now agent fetches some information, and then it asks you whether you are satisfied with this information or not, and then you give in some feedback, and then it again plans in and takes some action. So that is what PXP protocol is. So it can be, let's say you are working in an organization and you have an intern working under you, and that intern, you have assigned some task, and that intern comes again and again, have I done this correctly? Have I done this correctly? And then you given those feedbacks. So that is PXP protocol. Then there is some protocol called as LOCA protocol. This LOCA protocol is basically you can imagine, let's say that there are freelancers who work who do the freelancing work. So for them to verify their identity on all these freelancing platforms, they need to either create a profile, or maybe they have some unique identity of their own. So LOCA protocol basically is concerned with making sure that agents, whoever are working in the system, they are identifiable, they are accountable, and they are ethically aligned. That is what it defines. And then there can be web agent protocol. So what is web agent protocol? Let's say that these protocols, what they do is, let's say you are interacting, you are a human who is interacting with the web, and we are screen recording what all things you are doing on the web, what all things you're searching, what all things are you navigating through. And then we give this information to an agent, and that agent tries to replicate that human behavior. So this is what an web agent protocol does. It defines the framework, or the interaction way, by observing how humans interact with the web. This completes the human agent protocol section. Next, I told you about robot agent interaction protocol. So I told you that There can be agents interacting with physical robots, and then they make decisions. For example, there is a robot in the warehouses of big companies like Amazon, who is responsible for uh, putting these card boxes and at the right places. So what protocols are used there to give directions to these robots, or how agents interact with these robots is using this crowd ES protocol. It basically scans through the area, what pathways can it take and everything. So it creates a simulation kind of an environment, and then it learns how to navigate through uh, the crowd. For example, a self-driving car, how a self-driving car learns the environment. Then there is something called a spatial population protocol. It's one of the proposed protocol. This is basically, let's say, there are two people, there is a lot of fog all around. You have gone for a trekking, and then there is a lot of fog all around, and you don't know how to come back. So what you'll do is, all the people who have gone for trek, you might hold your hand, or maybe you will talk to each other, and then person one talks to person two, person two interacts with the person three, and that is how the communication happens. And this is how the spatial protocol also works in. So agent or the robot one interacts with agent two, and agent two interacts with agent three, so on and so forth. Then we have another category, which is system agent protocol, which I said, let's say an agent is responsible for shipping your containers, or maybe spinning your containers and then shutting them down. So for this, Eclipse has defined an LMOS protocol, which is nothing but, you can imagine it as an internet of agents. So there are a lot of agents, and then all of them are connected to each other. And Eclipse LMOS protocol defines how these agents would be interacting. So you can see that there's the circular interface, and then there are a lot of connections between all these agents that you see. So it enables agents to discover, connect, and collaborate all agents with each other. Another protocol within this category is the agent protocol. So it is an open API specification. This is actually the web page of this particular protocol, which you can explore. And again, it defines how different agents should be interacting with each other, but it has some different specifications of defining it. It is defined. It uses open API specifications for defining those rules. Now we have actually briefly touched upon all the protocols that were defined within this research paper. And as I said, it contained a lot of protocols, but I tried to give enough time to those that were very important. And then I introduced you to all the protocols that were actually mentioned in this paper. Now we know that there are so many protocols, but how do we know which one is better from the other? Or how do we actually evaluate how these protocols, how good are these protocols? Because if you just keep on studying, studying, and studying, and if there is no examinations held, probably you would not be knowing what significant progress you would have made in that particular subject. Similarly, if we just keep on defining certain protocols, but then we don't set any benchmark on um, how do we evaluate the performance of these protocols, it is of no use. So this paper has actually defined these dimensions on which we can evaluate the protocols. So one is efficiency. There are like basically seven dimensions: scalability, security, reliability, extensibility, operability, and interoperability. And within each dimension, they have specified multiple key metrics. So if I talk about efficiency kya hoga? Let's say if you have a friend who replies instantly to your messages on WhatsApp, then you would actually find interesting to talk to that. You will be interested in having conversation with that friend. But if, let's say, you have a friend of yours who doesn't replies or takes a lot of time to reply, probably you will prefer not interacting with that person a lot. So when I talk about efficiency, it is basically how quick agents are able to actually address your queries. And for that we judge them by latency. Latency मतलब उनको कितना टाइम लग रहा है आपको मैसेज भेजने में, मैसेज पार्स करने में. Throughput, if I talk about this term throughput, it is basically within a specified period of time, let's say within 1 second, how many number of messages are they able to process. That defines the throughput. And then resource utilization. So we need to make sure whatever resources are being utilized, they are how much, let's say, the battery or the phone data, if you're having interaction over chat, it is draining. So how much resource utilization is being done by those agents. So this is how we define how efficient an agent protocol is. Now the next important concept is scalability. So when I talk about scalability, let's say you visit your favorite restaurant on weekdays, you would probably notice that the service provided there is quite good compared to maybe when you are visiting them on weekends, because what happens during weekends is there is a lot of crowd during weekends, and then the service of that restaurant becomes slow. So when I talk about scalability is basically, let's say if I keep on adding more and more agents, I don't want the performance to be affected. So I want the performance to be maintained. So for that, I define the scalability as a parameter. And scalability, again, it has got some three metrics. One is node scalability. When I talk about node scalability, what I basically mean is कि मैंने बहुत सारे agents add कर दिए, but I still don't want कि मेरा performance of the entire system should be degraded. When I talk about link scalability, let's say if agent 1 is interacting with agent 2, is interacting with agent 3. Now, agent 1 could just be interacting with agent 2, but let's say I added one more link that agent 1 is now interacting with agent 3 as well. Now, agent 3, let's say previously was just interacting with agent 1, but now I have added one more link that it is interacting with agent 2 as well. So, the more the number of links I add, more communication pathways are created, and I again don't want that the performance of my entire system should be affected. So I would evaluate, is my protocol able to justify when even if I'm scaling the links, it is performing well. Talk about then it has something called as capability, which is basically how much agreement. Let's say there is a party and then you and your friend decide, okay, I'll bring this, maybe I'll bring fries and then maybe you bring cold drinks. So similarly, when agents are interacting with each other, they should be able to distribute the tasks well, and then protocol should facilitate this distribution of work between the agents. The next parameter, which is a very important parameter, is security. So, if I'm to evaluate an agent protocol, I need to make sure that it actually ensures the security. I'm able to identify all the agents that are the part of the ecosystem. I should be able to probably give role based access, and I should be able to actually protect the sensitive data. So the sensitive data should not be exposed to the outside tools or to the external resources. It should be protected. Then comes the another important topic, which is reliability. So let's say if there was a request made, and if that request uh, if that request was made, for example, there's one PC and this PC is requesting some information to another PC. If this PC2 fails to respond, if it is down, let's say the server is down, it fails to respond, there is a acknowledgement that is made in the TCP protocol. And if it doesn't, the PC1 doesn't receive this acknowledgement, it again, after a certain timer, it sends the request again, so that the requests are actually addressed in the ordered manner. So same thing should happen with the agents as well. So let's say that there is some request made. If the sender agent has not received an acknowledgement from the receiver agent, it should probably resend the same packet again, or resend the request to the receiver agent. And then if there are a lot of communications happening between agent, we need to limit the number of messages that are delivered within a set time window, which to which we talk about something called as flow control and congestion control. Again, you can read, there are a lot of technical terms and formulas mentioned here, which you can read in detail. I'm just giving you an overview of what all these metrics are about. Uh, Another important parameter is extensibility. So I'll tell you one thing about MCP. When MCP was launched, it had support for HTTP initially, and later on they added lot of enhancements on this MCP protocol. Now it can even actually MCP protocol and has support of HTTP ES, so event streaming as well. So basically, as technology advances, we want that whatever existing systems we have made, we should be able to navigate to the evolving setup. So there should be some backward compatibility that these protocols should offer. It should not be, for example, LangChain. When LangChain 0.1 was introduced, and then the LangChain version, new versions were introduced, the backward compatibility was actually lost for a lot of functions or offerings that they had offered, and it was the entire code bases that were present earlier were of no use later on. And then we also want, based upon the changing technology, these protocols should be flexible enough to accommodate any new changes that are being made in the current scenario. So this is about the extensibility part. Basically, if I add a new requirements, how these protocols are able to incorporate these new requirements. Then there are two important terms. One is operatability, and then second is interoperability. If I talk about operatability, I basically mean is how are these protocols, how easy is for me to actually implement this protocol. So maybe I just need to read 2 3 lines of code and then I'm able to implement it, versus I'm reading a whole 50 100 pages of documentation. So the ease of implementation accounts for the operatability section, and the way how these agents can be deployed on multiple systems. It can run maybe on your phone, it can run maybe on your laptop, and then your laptop can be a Chrome, let's say Windows laptop, it can be an Apple, it can be a Linux based OS operating system. So there should be compatibility between these agents to serve across different browsers, across different systems, as well as across different networks. So this is what we talk about in the interoperability. So if I'm to summarize, as I said that this research paper has mentioned 7 dimensions in which we can evaluate these protocols. As of now, there is no set standard, the de facto standard, but yet this is a very broad categorization, or the way this protocol evaluation can be conducted and what all metrics can be taken into account when I talk about these dimensions. Now, we saw how what are all different protocols existing. We saw how can these protocols actually be evaluated on what certain dimensions. Finally, in this paper, there is a very interesting case study, or a small use case analysis that is given, that allows us to compare all the known protocols or the important protocols. For example, let's say that there is a user who is trying to actually uh, interact, is sending an instruction to plan a 5 day trip from Beijing to New York. Now, if you were implementing MCP protocol, what would happen is that the user sends a request to a travel agent, and that travel agent will have multiple clients interacting with the server. And this client will send the request to the flight server, to the hotel server, to the weather server, and then that is how this communication will happen. So MCP is basically a single agent is responsible for invoking all the tools. Now, next, what we have is we can have A2A protocol, which is inter-agent protocol. And what it does is that in the inter-agent protocol, there is an entire system, and within the system, we have certain departments. And within those departments, we have agents, and those agents can interact with each other. So this is an agent to agent protocol interaction. Then we talked about ANP protocol, and what ANP protocol does is it allows cross domain interaction. So here, instead of having everything within one organization, we have a separate hotel system, we have a separate weather system, we have a separate airline system, and within these separate organizations, we have certain agents that are existing, and we are requesting the travel agent, and that travel agent is coordinating the request with all the other agents as well, and is serving to the request of the user. And then we have Agora protocol, as I discussed. So Agora protocol would define the PD documents, descriptions, protocol descriptions, and it enforces the user request in natural language. It extracts the key information from that request, and then it generates the protocol definition for each of the key pointers, key information that is extracted. And then that is how we define a flight protocol, we define a hotel protocol, we define a weather and the budget protocol. So this is about, this is a use case that defines how all these protocols are interacting to the user request within the same description or the organization. Now, the last topic that is mentioned within this research paper is what do we foresee in future? So there, what outcomes do we foresee in future? And they have again categorized it into three categories. One is the short-term outlook. So the short-term goal for us is that we need to make sure that these protocols are they actually maintain the privacy, they protect the sensitive data. The midterm goal or the outlook would be that instead of defining these protocols later on, maybe during the pre-training process of the LLMs, we are able to uh, actually enforce some protocol knowledge at that very time. So it is easier for us to build multi-agent systems. And the long-term outlook would be how can we create a very big network of agents, and then we are able to define those networks. This concludes the entire paper. As I said, it's a very big survey paper, and it was organized in certain parts. So the very first part was the significance of agent protocols, and then the two-dimensional classification of those protocols, in which we talked about the context-oriented and inter-agent protocol. And then later on, it was about how do we actually evaluate these protocols, how good are they, on what dimensions should we be evaluating these protocols, and then what future outcomes do we foresee. I see some questions. MCP handles agent to tool communication, A2A handles um, agent to agent communication. But what happens when an agent A wants to use agents B tools? That's a cross layer problem, right? That this is a cross layer problem, and it again happens step by step. And this is a gap that is mentioned as addressed by Prashant. Then I think there's one more message. The agent network protocol uses decentralized identifiers. How does this solve the problem of trust when agents from different companies need to collaborate? So it's a good question. Given that agent network protocol, it is using decentralized identifiers, but it also incorporates end-to-end encryption as well. So that is how it addresses the problem when there are agents that are from different companies and they need to collaborate. They would probably do it through an end-to-end encryption system. um, I think I've addressed the questions,
Hi, Jyoti.
and
Can you
this
hear me?
completes this research paper. This concludes this research paper session. If you have any more questions, I can probably address those. JSON format provide the flexibility of a custom UI without security risks of executing arbitrary JavaScript or HTML. So, when I talk about JSON format, uh, basically it takes in these key value data. So, again, we can define the certain keys and then we can define the certain values for it compared to the HTML or the JavaScript code. So JSON files are basically very secure way of storing the data and then making sure the agents are interacting with these JSON files and pulling the relevant information instead of exposing the entire information all at a single time. So that way, declarative JSON format would give more flexibility and it would also not be there would be no security risks as well. Asked by Suhaib. Okay. I hope so this answers your question, though it is a bit out of context from what we have been covering here. Any more questions are there? Okay, you walked us through context-oriented versus inter-agent distinction. In your understanding, which side of this classification is more mature now? The agent-to-tool protocols like MCP or the agent-to-agent ones like A2A or and ACP? Why do you think one is ahead of the other? To be very honest, as per my opinion and as per the understanding I've developed from this research paper, of course, agent-to-tool protocols like MCP is on a more mature side, as this research paper itself mentioned that this is a de facto standard in the industry. So it is the very first pointer that helps us that actually justifies my statement saying that context oriented protocol on that side we are more mature. And if I talk about inter-agent protocols, though we have made significant progress in the A2 and ACP section, but the problem is that again multiple agents interacting with each other is still is a black box, and there are a lot of things that we are still not able to identify, and through these protocols we want that each and everything should be clearly identifiable. So I would again say that the context oriented section is the more mature section as of now. We have Google's A2A and IBM ACP both solving agent to agent communication, but with different approaches. Which one would you lean towards? Okay, there I would actually, again, it depends upon the preferences. So maybe you can try implementing Google's A2A and then IBM's ACP, and then actually evaluate as per the use case or the problem statement which one works better. And I would personally not make a comment on which one I lean towards because I have not, to be very honest, evaluated them in terms of implementation part. I've just gone through this research paper in terms of um, the another question that I have here is in a multi-agent system, where does the boundary lie between A2A and A2 UI? Can an agent use A2 agent to agent to delegate a task to another agent, which then uses A2 UI to talk to user? Of course, we can do that. In a multi-agent system, see, in the inter-agent protocol systems, whatever protocols we have discussed were how the protocols that were defined for the agent to agent interaction and agent to UI interaction. Uh, Basically, I think again it would be defined by the context oriented protocol, if I'm not wrong, because in the agent to agent, it's just two different agentic systems talking to each other. How can I begin with creating my first research paper? I don't know the exact process, although I do understand gaps after reading some papers. Um, Okay, I'll just answer this last question, which is about creating your first research paper. So, first of all, kudos to you that you thought of investing your time into research. So, I would say, like, whatever thought you just go through some previous research papers and do some literature survey on whatever topic you have, and then probably document them all at a place, and then plan on how do you implement, how do you aim to solve those problems, or how do you plan to address these gaps, and then uh, again document everything in a doc format, or through overleaf you start writing this paper, and then reach out to the conferences and journals, sharing your papers, or providing the abstract about the study that you're working on. Prashant, you can take over. Thank you so much, everyone, for attending this session.
So thank you guys, and I would like to thank Jyoti ji. She have explained quite well. So it's quite interesting to see and go through कि कितने सारे protocols हैं हमारे पास. अभी just 2 to 3 years back हमने agents के बारे में सुनना start किया था कि they are getting started to use in industry, but right now we see कि उनके agents के बीच में communication के बारे में अभी हम सुन रहे हैं. Think like after some years, industries and agents will be talking to each other, taking some very strong decisions and automating a lot of things that we have even we haven't imagined ever. तो इस तरह की चीजें होंगी. काइंड ऑफ इस पेपर में अगर देखा जाए तो काफी सारे इंटरेस्टिंग प्रोटोकॉल्स के बारे में डिस्कशन किया गया है. एनसीपी, एसीपी. आई वुड से कि आप लोग कोई ना कोई प्रोटोकॉल ट्राई करें, और इस प्रोटोकॉल को ट्राई करके आप व्हाट्सएप ग्रुप में, हमारी कम्युनिटी के व्हाट्सएप ग्रुप में शेयर करें कि व्हाट यू हैव फाउंड इंटरेस्टिंग. This kind of a activity I would like to you guys to test it, or like, and thanks for joining today's session. आज and I would like to say sorry because हमारा communal platform उस तरह नहीं चला जिस तरह चलना चाहिए था, but the thing is next time we will host it properly so you can mingle and do a lot of communication and chats to here. एंड आई वुड से कि इस तरह के नए एंड मोर इंटरेस्टिंग पेपर्स हम लाते रहेंगे और डिस्कस करते रहेंगे. वी विल डिस्कस अ लॉट अबाउट दीज थिंग्स, ताकि आप लोगों को ये कुछ नया और कुछ नया जानने को मिले, और हम लखनऊ के अंदर और इस यूपी के अंदर एक नया इकोसिस्टम प्रिपेयर कर सकें जहां रिसर्च करना और उसे समझना काफ़ी आसान हो सके. कोशिश करेंगे हम और भी इंटरेस्टिंग सेशंस लाएं, जैसे पेपर लिखा कैसे आता है, पेपर पे हम काम कैसे कर सकते हैं, और इन पेपर्स में नए टॉपिक्स और नए सब्जेक्ट प्रॉब्लम्स को कैसे फाइंड आउट करेंगे. दीज टॉपिक्स वी विल कवर सून एज वेल. So thanks for joining today. Let's close this session, and I would like to ask you to share the feedback to our community channels on WhatsApp or Discord, wherever you feel good. Please share the feedback. Thank you for joining. Let's end the session today.